Alright, so we are starting the advanced part of our journey, and again, I'm not saying that this is the last leg. We will again repeat the same thing. We'll do that in iteration like we always do, just to make sure that whatever we learned, we do that in a couple of iterations so that when you guys go for your actual SAT exam, you will find it like a breeze. Okay, so as I mentioned yesterday, we started the advanced algebra and we briefly touched upon whatever we kind of knew about the linear equations, the different ways to solve a linear equation. We looked at what do we mean by solving a linear equation. If you have two equations, how do you find one solution versus multiple solutions, or infinite number of solutions versus no solution. So we will continue with that journey, and what we want to cover today are, I have put that in the WhatsApp group. Let me just quickly read it for you guys and then we'll get going from there. So we'll talk about the word problems. How do we translate word problems into equations and then use that for solving it? How do we understand different properties or relationships of linear equations and deal with harder word problems? And then we'll talk about graphing linear equations and functions. So many of the things that you guys already know. So as I mentioned, you will find things getting more interesting, much more deeper, and it would need a lot more focus from your side. So let's get started. Are we good to get started? Ria, Neil, where's Sarah?
She's coming.
Okay. Rehan, Chris, okay, alright. So I know Dev is not joining today, and Arush, Daivik and Sahib, they are out on a family trip. And Haspita also, I think she has a class today, so she'll not be able to join today. So let's get started. So what I've done is, all these concepts of translating word problems into equations, or understanding different types of linear equations, or graphing linear equations and solving problems, all these are known concepts to you guys. What we'll do today is we will break our head with these problems and see what kind of things that we're going to deal with in the real exam. So I have put some questions for you guys. Let's go through them. First one, again, these are the set of questions that I sent to you guys in WhatsApp. Some of you who have access to it, you would have probably seen it. Let's quickly look at it. First problem says, a rectangular garden has a length of 60 feet. A rectangular garden has a length of 60 feet, a width of W feet, and a perimeter of 200 feet. Which of the following equation best models the garden's perimeter? So again, I'm repeating the question, reading it one more time. A rectangular garden has a length of 60 feet and the width of W feet and the perimeter of 200 feet. This is the perimeter. Which of the following equation best models the garden's perimeter? And we have certain options: 60 plus W equal to 200, this is one. 60 plus 2W equal to 200, that is the second one. 120 plus W equal to 200, that is the third one. And fourth one is 120 plus 2W equal to 200. And trust me, this one doesn't need any solution. Okay, hey Tansi, hello Saranya. So Tansi and Saranya, we are continuing with what we started yesterday. We started talking about advanced algebra, and we just touched upon the basic concepts of all different types of linear equations. What does it mean to find one solution, no solution, multiple solutions, or infinite solutions? And then we brushed up the concept that we knew. So we are going to deal with more and more problems relating to the concept that we already know. So you'll find that I'm not teaching anything new. We are practicing what we already know. So that's some problems. So yes, Purvi. So I have put this question. So some of you joined late. I put a question saying, the question says, this is a rectangular garden with length 60 feet, width W feet, and perimeter 200 feet. Which of the following models the formula for the perimeter that you see from the question? Yes, Purvi, go ahead.
I think the answer is D.
Okay. Praneeth, Chris,
4.
same option D, yeah. 4 or option D, yeah. Chris, do you agree with what your friend said?
Yeah, I got 4.
Yeah. So see, this kind of question, I wish you all get this kind of questions in your exam, because this doesn't need any solution, any calculation. You just have to draw this like I drew. This is length, this is length, this is width, this is the rectangular parameter, rectangular garden. So opposite sides are equal and parallel. And what is the perimeter length of one side? 60 plus 60, W plus W. 60 plus 60 is 120, W plus W is 2W. As simple and as easy as you can think of, right? Rehan, do you agree with what your friend said? Neil, any issue? Ria? No? Alright. So this was an easy one, right? And again, this is easy because as soon as you heard rectangular garden, this is the first thing that came to your mind. After that, whatever we did was a kid's play, correct? Let's look at more of the problems. We'll try skimming through these problems quickly, because I don't have any plan of doing each and every problem. I'm just trying to make sure that you guys are very clear when it comes to deriving an approach and solving a problem, okay? If you guys are clear, confident, I have no reason to waste everybody's time. Let's look at the second one. The property taxes in a town decreases as the distance from the local elementary increases. Little interesting sentence. The property taxes in a town decrease as the distance from the local elementary school increases. So if your school is here and your house is here, so this is school. Let's say this is house 1, house 2. And this is what keeps on getting constructed in our mind when we read the question, right? It says, the property taxes in a town decrease as the distance from the local elementary school increase. So if this house is closer, taxes are higher. As this distance increases, taxes are, you can look at it this way. Closer the house from the school, higher the taxes. Farther the house, lower the taxes. That's what it says. The greatest property taxes are 4.5. Greatest is 4.5. And for every 10 miles from the school, property taxes decrease by 0.5 percentage points. And for every 10 miles from the school, the property taxes decrease by 5 percentage points. If a house's property taxes are 3%, this is the greatest, and this is the house. Let's say this is my house or your house. Says, if a house's property taxes are 3%, what is the distance of that house from the school? So now we have heard so many sentences. Let me read it one last time. The property taxes in a town decrease as the distance increases. More the distance, lesser the tax. The greatest property taxes are 4.5%. Let's say this is the house that is with the highest property tax, and that is 4.5%. And for every 10 miles, the property taxes decrease by 5 percentage points. So let's say From here you go 10 miles. If this is the house with highest property tax, that is 4.5%. You go 10 miles, it decreases by 5.5 percentage points. So probably after 10 miles, if this distance is 10 miles, this will be 4%. Okay. If a house's property taxes are 3%, what is the distance of that house from the school? And you have 4 options: 10 miles, 20 miles, 30 miles, 40 miles. What do you guys think? Everybody heard the question, right? That this is the school. Farther the distance, higher the farther the distance, lesser the property taxes. The highest property tax is 4.5%, and for every 10 miles, property taxes decrease by 0.5 percentage points. If the house's property tax is 3%, what is the distance of that house from the school? How do you think about it? Yes, Praneeth.
30 miles.
30 miles. Okay, Purvi. I'll come back to you, Praneeth, just to pick your brain to understand why did you arrive at 30 miles. Yeah, Purvi.
40 miles.
You think 40 miles? Okay. Anybody else? Any other option? 10, 20, 30, 40. These are 4 options. Okay. Ria, Rehan, Tansi, Saranya, anybody? Chris? I have 2 answers so far, okay? I have 4 options: 10, 20, 30 and 40 miles. I got 2 options, okay? Anybody else? Ria, what do you think, beta? Thinking about it. Neil?
I think it's 30 miles.
You think it's 30 miles? How about you, Saranya?
I'm still working on it.
Okay. Let's see what Chris says.
I got 30 miles.
You also think 30 miles, okay? Alright. Let me see. Okay. Alright. Okay, yeah, Tansi.
I got 30 miles.
You also got 30 miles. Hello, Sarah. Okay, so now let me pick some of you's brain. Okay. Praneeth, tell me what did go in your mind to arrive at 30 miles?
So, since we're trying to find out the distance from 4.5 to 3, and each 10 miles is a 0.5 decrease, I took 4.5 and subtracted 0.5 until I got to 3%, and I had to do it 3 times, meaning 10 miles times 3, getting to 30.
Okay. Now, Purvi, you tell me what went in your mind. Okay, I'm not trying to conclude whether 30 is right or 40 is right. I'm just trying to understand what went in your mind to arrive at 40, beta.
I think the question says that, like, if it's 4.5%, like, I feel like that house is like the closest to school. So I was like, wait, so if the house is like 4%, it would be 20 miles, and then if it was like 3.5, it would be 30, and then for 3 it would be 40.
Okay.
I don't know.
I was kind of thinking on those lines, Purvi. Okay, so I was that's why I was trying to understand if you were thinking the way I was thinking as well. So that's the reason I was trying to understand from you. Chris, what did you think the way Praneeth was also thinking to arrive at 30?
Yeah, I said 4.5, so I did 4.5 minus 3 and I got 1.5. And then that's like 0.5 times.
Three times basically.
Yeah, so then I just multiplied that by 10.
Okay. Tansi, same way?
Yeah, basically same.
Okay. So here's the small thing, okay? I was initially thinking that this house, which is having highest taxes, is 4.5%. And this is highest because this is the closest to the school. So the way I would visualize this is, oh, this is probably not the same locality, same place where the school is. Not on the same property though, but right next to it. Meaning it cannot get any closer. And I would probably assume this distance being 0 maybe, right? I mean, some of you live in the same community, exact right next to the school, right? Those are the houses which have highest taxes. So instead of taking the school as a reference point, I will take this as reference point because school have no taxes, right? And school doesn't have to pay taxes. So I'll probably take this house which is closest to the school, maybe bordering the school, is where the highest taxes are, which is 4.5%. And every 10 miles that I move away from the school, I'm paying 5.5% less taxes. So basically, to get to 3, I have to move 10 miles, and one more 10 miles. So that is how 0.5 plus 0.5, 1.5% tax is less. So that is how it is coming to 30. So everybody thinking in this right direction. Only thing was, when I was thinking about it, I was thinking, okay, maybe the highest taxes house is 10 miles away. That was my first doubt that I had in my mind. But then I kind of recalibrated my thinking process to say, okay, fine, no. I'll probably think of this being the school right next to the house right next to the school. Yeah? Does it make sense to everybody? Okay. Alright. So Sarah, you joined a little late, but I'm assuming that you have not missed anything, and even if you did, we'll catch up. Yes, Purvi.
But how would you know? Like, you can't just assume it's like 10 miles away because it doesn't say in the question.
Right. No, so that's a wrong assumption that I had made, right? I said, which house has the highest taxes? The one that is right next to the school, maybe. There is no meaningful distance from the school that I'll assume for this house which has highest taxes.
Yeah, okay.
So that's why I will count this distance as 0. Maybe 10 feet apart, maybe 20 feet apart, right? So that is why I'll just ignore the distance between the highest taxes house and the school. And then I'll use that as a reference point to count every 10-mile movement. Make sense? Okay. Alright. Saranya with me? Ria with me? Okay. See, it seems like I have made some of my kids upset and they don't talk to me, just use the sign language, huh? Okay, no, I'm just kidding. Alright, let's go to the next question. And again, it's all about practice. Math is all about practice, right? So, let's look at another problem. I have an equation with me, or this question has an equation. Let's look at it. And this equation is t equals v over 1.1 plus 0.5. This is just a simple equation that we have. Okay? And the word after that is a cylindrical ceramic mug with a volume of V cups is filled with water and placed in a microwave oven of constant power. a cylindrical ceramic mug. Let's say this is the mug. Okay, and this is the handle for the mug. Okay, a cylindrical ceramic mug with a volume of V cups. So the volume of this ceramic mug is V cup. That V is the number of cups. V cups. Okay, meaning like we measure volume, fluid volume in cups, right? So V cups. That is the volume of this ceramic mug. Is placed in a microwave oven. So this is my microwave oven. See how good this microwave oven looks. Okay, this is inside the microwave oven of constant power. It takes approximately T minutes for the water to begin boiling as given by the equation. It takes T minutes for the water to begin boiling as given by the equation. What does 1.1 mean in the equation? Oops, what did I do? Okay, what does 1.1 mean in the above equation? It's an interesting word problem, okay? We have to interpret or read this. This is the equation given. T equals V by 1.1 plus 0.5. V is the volume of the, okay, let's not worry about it. It says that there is a ceramic mug. This ceramic mug, which has a volume of V cups, is placed inside the microwave oven with a constant power. This equation represents that it takes T minutes to boil this water in the cup. It takes T minutes to boil this water in the cup, in this oven. It says, so this is a volume, this is the time. It says T minutes, it's in minutes. So from this equation it says, what does 1.1 mean in this equation? And again, trust me, I have not seen this equation before. I will read it from this question and interpret. It says this gives 4 options, okay? First option says, the volume of the ceramic mug can be a maximum of 1.1 cup. The volume of this can be maximum of 1.1 cups. Okay, I don't know what that means. Second one says, every 1.1 additional cup of water take 1 more minute to microwave and boil. It says every 1.1 additional cup. So this is V cups. Let's say this is 5 cups. Okay. It says, if I read this equation, says it takes 1.1 means that every 1.1 additional cup of water takes 1 more minute to microwave and boil the water. Okay, that is second one. Third line says, third option says, the time it takes to microwave and boil 1 additional cup of water is 1.1 minute. That's the third option. I don't know. I will rely more on your interpretation of this one, okay? The fourth one is, the minimum amount of time to microwave and boil any amount of water is 1.1 minute. So there's a story in this equation. Now, what is this equation says as per the question is, V is nothing but the volume of the ceramic mug, which is kept in the oven for boiling the water. V is the volume of the ceramic mug, meaning if you fill it, let's say if it is V is 1 cup, you'll put V equal to 1 here. 1 by 1.1 plus 0.4, this is the total time taken for boiling the water. If it is 2 cups, you'll put 2 here. 2 by 1.1 plus 0.5 will be the time, that many minutes is the time taken for boiling that water. If you put 3 as the volume, so if the ceramic mug has capacity and volume of 3 cups, you'll put a 3 here. 3 by 1.1 plus 0.5. That is the total minutes taken by the microwave for boiling the water. So this is how we'll interpret. But the options given to us is, first option is volume of the ceramic mug can be maximum of 1.1 cup. That is the first option given. Second option is every 1.1 additional cup of water take 1 more minute to microwave and boil. Every 1.1 additional cup will take 1 more minute to microwave and boil. Third option is the time it takes to microwave and boil 1 additional cup of water is 1.1 minute. And fourth option is minimum amount of time to microwave and boil any amount of water is 1.1 minute. What is your interpretation? And I know this is a little offbeat problem. It has more to do with interpretation than anything else. Let me see what is going in your mind. You all heard the question, right? Chris, Praneeth, Purvi, Saranya, Praneeth, everybody, Priya, Rehan, Sarah, yeah. Now tell me, what is cooking up? Anybody? Okay. This, do you guys want me to give it a shot? And trust me, my approach will be as simple as you can think of. Because my biggest problem in life is not being intelligent. Who all believes that your teacher is not intelligent? At least one person. Okay, I'm just kidding. Okay, so again, what I mean by that is, I will not overthink about these things, okay? That's what I mean by not being intelligent, okay? Because I have a story always for everything that I do. So here, this is the equation. And from this equation, I'm told that V is the volume in cups of the mug, of the ceramic mug that I'm putting in the microwave. Okay? And T is the time taken in minutes by the microwave for boiling the water. So now look, let's do it in a very simple way. If V is 0, what does it mean? Meaning the volume or the amount of water in the mug is 0. I will not worry about it. Okay? If there is no water, what is that we are trying to boil and what we are trying to figure out? Right? So I'll probably start with 1. Meaning I'm saying, if I'm talking about 1 cup of water, meaning my volume of the water in the cup is 1 cup. This is the total number of minutes it will take to boil the water. Meaning 1 cup of water in this mug will take this many minutes. How about 2 cups? It becomes 2. How about 1.1 cup? It becomes 1.1 divided by 1.1 plus 0.5. Or this becomes 1 plus 0.5. That is 1.5 minutes. How about 5 minutes? 5 cups of water. I'll put a 5 here. 5 by 1.1 plus 0.5. These are the options I have. Now let me go back to, these are the things that I can think of mathematically. Now let's look at the first one. First option says, volume of the ceramic mug can be a maximum of 1.1 cup. Volume of the ceramic mug can be a maximum of 1.1 cups. That's the most stupid option that we can have. The question doesn't say that at all. It doesn't say the maximum volume of the cup or the mug. Let's rule that out. because I'm talking about 1 cup, 2 cup, 1.1 cup, 5 cup. And my question doesn't have any restriction like that. So I will rule out that option which is kind of misguiding us. Do you guys agree? First option I've ruled out, okay? Are you guys with me so far or no? I mean, feel free to contest, okay? Yes, somebody has raised hand. Nobody? Alright. Now the second option is every 1.1 additional cup of water takes 1 more minute to microwave. Okay, every 1.1 cup. So 1.1 cup took me 1.5 minutes. Every 1.1 cup, meaning if I go from 1.1 to 2.2, meaning I'm adding 1.1 to my initial volume of 1.1. If I go to 2.2, what does happen? 2.2 cups will take how much time? My volume becomes 2.2 by 1.1 plus 0.5. 2.2 by 1.1 becomes 2 plus 0.5. It takes me 2.5 minutes. Oh, when I increase my volume from 1.1 to 2.2, meaning I added additional 1.1 volume, I took 1 minute extra. 1.5 went to 2.5. What if I go to 3.3, meaning I'm adding another 1.1 cup. So it becomes 3.3 divided by 1.1 plus 0.5. This is equal to 3. So this becomes 3.5. Oh yeah, this makes sense. What we are seeing is every addition of 1.1 cup is adding 1 minute extra for the microwave to boil the water. It went from 1.5 minute to 2.5 minute to 3.5 minute. So second option makes sense. Yeah. So second option looks to be the right option. Do you guys think so? Riya, Chris, Praneet, Purvi, Sanya? No? Yeah? Riya, do you agree with her? Riya is not agreeing. Riya wants to contest. Huh? No, okay. Okay. Neil and Sarah, Rehan, you guys agree?
Yes, sir.
How about Tansi? Tansi, do you agree with her?
Yes, sir.
Okay. So see, this was the equation given where V was the volume in cups of the water here and T is the time taken in minutes. It was saying T is the time taken in minutes to boil the water of this many cups. Did we do anything fancy? No. We said okay, fine. What if I have 1 cup of water? Okay, it takes this much minute. What if I have 2 cups of water? It takes this much minute. What if I have 1.1 cup of water? Because I wanted to simplify this calculation. I saw that it takes 1.5 minutes. So the second option was every 1.1 additional cup of water take 1 more minute. And we just put that value and we saw that. So that means this is a valid option. Let's look at the third and fourth option also. You never know. I mean, we might be agreeing for this as an option, but something might be more legitimate than this. Let's look at the third option. The time it takes to microwave and boil 1 additional cup of water is 1.1 minute. Okay. See, every 1.1 additional cup of water takes 1 minute. 1.1 cup extra takes 1 minute extra. That is what we saw in the previous option. And we did the calculation also. Every 1.1 cup extra takes 1 minute extra. This option says 1.1 cup extra takes 1 minute extra. What this option says, the time it takes to microwave and boil 1 additional cup of water is 1.1 minute. No, 1.1 cup takes 1 minute. Why would 1 cup take 1.1 minute? More water, less time. Less water, more time? No ways. Third option, we are ruling out. Do you guys agree? Yeah? Everybody? It's simple calculation, right? 5 bananas come for $2. Would 4 bananas come for $2.5? No ways. Correct? It's a rip-off. I would not go to that store if they ever do that. Same way here. I will not use that microwave ever. I will throw it in the dumpster. If 1.1 cup takes 1 minute, 1.1 cup extra takes 1 minute, why would 1 cup take 1.1 minute? I would rather boil 1.1 cup extra in 1 minute rather than boiling less water in more time. I'm wasting electricity, isn't it? And every unit of electricity that we waste, we pay money for that, right? So this is not the right option. Let's look at the fourth one. The minimum amount of time to microwave and boil any amount of water is 1.1 minute. That is a minimum amount of time to microwave and boil any amount of water is 1.1 minute. That doesn't hold any water actually. Minimum amount of time to boil. Minimum amount of time. See, minimum amount of time will be when my water is almost 0. 0 by 1.1 plus 0.5. If I am talking about boiling 1 drop of water, 1 drop, which is probably 1,000, 10,000 or 1 millionth of a cup, that will also be close to 0 plus 0.5. So minimum amount of time that I would need to boil 1 spoon of water would be somewhere closer to 0.5 minutes, not 1.1 minute. So that is also to be ruled out. Yeah. So again, this question, I mean, all these questions that we have dealt with so far, these are the questions that you will deal with in SAT as well. But does it require any calculation? No. It just requires us to do a thoughtful evaluation of the question, read the question correctly, interpret that in the most legitimate way, and then pick the right answer. Do you guys agree, or you want to raise your voice against what I said? I'm just kidding. Do you guys agree? Saranya, Thansi, Ria, Purvi, Sarah, Neil, Chris.
Yes, sir.
Everybody agrees? Okay. Okay. Then I will move on to the next question. Okay. Let's go to another question which might look little tricky to begin with. Okay. And again, it's a word problem. And the interesting fact is, you guys will deal with a lot of word problems in your SAT exam. Okay. That's the only way the examiners of SAT can make SAT exam or ACT exam look complicated to you guys. Because if you just look at the concepts, right, you guys have learned all the concepts. They also provide you a lot of supporting material like the formulas and all. They even let you use calculators. What is the means for checking your comfort with math? Only way is by giving you a lot more word problem. That is where they will be able to explore your conviction with respect to any problem that you're trying to solve. Let me read the next question. A bakery made 200 cakes in preparation for an upcoming holiday. Bakery made, this is a bakery. Let's say the bakery's name is Biryani's Bakery. Okay, I don't do baking, but let's give it a name. The bakery made 200 cakes in preparation for an upcoming holiday. Okay, maybe Christmas, maybe Thanksgiving, maybe the Independence Day, whatever be the reason. Each cake was made from 4.5 cups of batter. Each cake was made from 4.5 cups of batter. Okay? And 3.5 cups of frosting. So see how easy it is. 4.5 cups of batter and 3.5 cups of frosting. Okay. Which of the following shows the number of cups of batter? Number of cups of batter. Number of cups of batter. Which of the following shows the number of cups of batter? Represented by this, cups of batter. Okay. The bakery used as a function of F cups of frosting. Let me read it one last time. Okay? A bakery made 200 cups for an upcoming holiday. Each cake was made from 4.5 cups of batter and 3.5 cups of frosting. So every cake took this much batter and this much frosting. Which of the following shows the number of cups of batters? So this is the number of cups of batter. Okay, number of cups of batter is a function of cups of frosting. So this is like when you say y is a function of x. What do you mean is y is changing based on value of x. So here it says the number of cups of batter is a function of this function of cups of frosting. So basically it's trying to relate how the number of cups of batter and number of cups of frosting are related. And these are options given to us. Okay. B of f, number of cups of batter, equals 7 by 9 of f, where f is the number of cups of frosting. This is option 1. Option 2 is B of f equals 200 minus 7f by 9. Option 3 is B of f equals 9 by 7 of f. And then again, f is the number of cups of frosting. This is the number of cups of batter. These are 3 options. There is a 4th option also, which I ate. I did not take a printout of that, but I want you guys to still try and let me know how would you think about it. One last time reading the question says, for an upcoming event, they made 200 cups, 200 cakes. Every cake takes 4.5 cups of batter and 3.5 cups of frosting. From this information, it's saying, how would you represent the relationship between the number of cups of batter and number of cups of frosting based on this above information? And these are options given to us. Now tell me, here B of f is number of cups of batter. F is number of cups of frosting. So what is looking like your option that you would want to consider for relating these two? Everybody heard the question, right? Okay. I'll give you guys a moment of silence to think about it, and then we'll try doing it. Chris, you also heard the question, right? Ria, Chris, Neil, Sarah, everybody heard the question, I'm assuming, right?
Yes.
Okay. I'll give you guys a minute or two to think about it. And then tell me, are you leaning on one of these options, or the 4th hidden option is probably the option that you'd want to consider?
I think it might be the 4th option, sir.
Okay. I'll come to pick your brain bit, okay? To understand why you're thinking that way. Okay. Find a place for yourself and sit down as if you are not here. That means I don't want to hear a thing. That's not for you guys, okay? That's for my kid from the next class. Quietly take your things out and make sure that you're ready before your class starts without making noise. What's cooking up, guys? What's going in your mind right now? Saranya, Tansi. Okay, Tansi, you said probably fourth option. Tell me why you think so.
I don't know how to explain it. Just for me, when I'm looking at the options, it just doesn't make sense.
Okay. Okay. Anybody else? Praneeth, Riya, Neil, Sarah, could be anybody. Saranya. Anybody? Guys, speak up. Riya used to talk quite a lot. Nowadays she has gone very much muted. What happened, beta? All okay? Yeah, okay. Or you are bored of the teacher now. That this teacher is cracking bad jokes or not talk to him. Purvi, how about you, beta?
I don't know, I'm still thinking about it, sir.
Okay. So what we'll do is, just in the interest of time so that we can do at least one more problem. Rudraksh, I said, you're not here in the class yet. So make sure there is no sound, no background sound. Here, this is the option. This says 200 cakes are made and every cake takes 4.5 cups of batter and 3.5 cups of frosting. Let's say if I just want to find out the ratio between these two. Let's say B of F is nothing but number of cups of batter divided by number of cups of frosting. If I just put that for every cake, what do I get? 4.5 divided by 3.5. Is this correct? See, every cake takes 4.5 cups of batter and 3.5 cups of frosting. If I just put B of F is nothing but the number of cups of batter and F is the number of cups of frosting. If I just take the ratio of these two, this is what I come to. Equal to 4.5 is 4.5 by 3.5 becomes 45 by 35 into F, or 9 by 7 into F. 9 by 7 into F. This is 7 by 9 into F. Out of question. This seems to be the option. Did I do anything fancy here? No. I just had a ratio between the two. Number of cups of batter and number of cups of frosting. I just took a ratio of the two. Number of cups of batter, which is represented as B of F as per the question, and F is represented as the number of cups of frosting. If I just took a ratio of these two, that is equal to 4.5 by 3.5 for each cake. That's my ratio. So if I just look at that, I got this as an option. Now if you look at this, B of F equal to 200 minus 7F by 9. My number of cups of batters or number of cups of frosting has no relationship to the number of cakes that I am making actually. It says making 200 cups. If the business is booming, they might make 2,000 cups also, 2,000 cakes also, 5,000 cakes also. Doesn't matter, the ratio of frosting and batter has to remain the same. This is what is called proportion. That would not change. So the relationship between the number of cups of batters and number of cups of frosting is independent of the number of cakes that you are making. Unless you want to become as great a baker as me. I am horrible at baking, okay? I made cake once when I was small, in probably 8th or 9th grade. And I put as much quantity of flour as I was supposed to put the baking soda, and the vice versa. So imagine, instead of putting this 2 spoons of baking soda, I put 2 big cups of baking soda. Instead of putting 2 spoons of instead of putting 2 cups of flour, I put 2 spoons of flour. So cake turned out very big, very fluffy, but horrible in taste. So again, coming back to a serious discussion, what I'm saying is, my proportion of the batter and the frosting is independent of the number of cakes that I'm making. This ratio between the two will remain the same, right? I mean, that's how you ensure quality of any preparation or food item that you make, right? So that's why this is out of question. So without looking at the 4th option, this one I'm leaning towards. So Tansi, does that make sense to you, beta? You were thinking of 4th option, but I'm saying I'll probably lean on the 3rd option because this shows me the ratio between the two. Yeah?
Yeah, that makes sense.
Sharanya, do you agree with Tansi, if not me? Okay. Purvi, Riya, everybody? Praneet? Okay. Alright. So, so again, as I always keep saying, right? Any problem that you pick up, don't overthink about it. Because if you keep it simple, you'll be able to get to the root of the problem. I did not, even if this one was looking complicated, but with a simple common sense, I could think that, okay, number of cakes has no bearing with the ratio or the relationship between the batter and the frosting, because batter and frosting's relationship is depicted here. Every cake, regardless of how many cakes you are making, is dependent on their internal relationship or the ratio or the proportion, not on the number of cakes that you are making. So Sanvi, we still have 3-4 minutes for your class to start with, okay? Just bear with me. So what we'll do is, I'll just pick one more problem real quick. I'll just read it for you guys, okay? We will not try solving it. So Sanvi and Rudraj will hear the question for senior kids without worrying about it, okay? I'm just reading it. Just 1 second. Okay, all right. So let me quickly read that last question for you guys, and then Lovita, come on in, find a place for yourself. Okay? Yeah. I'm just finishing off the class for the senior kids.
Yeah, Chris, okay.
You can sit down. There's no senior kids here. Most of the kids are away. Have a place. And if you guys feel hot, I'll turn on the AC, okay? So far it is better. So let me do one thing. We have just 2 more minutes. I'll not read this whole question. I'll just read part of it, okay? No, this is not the one. Sir, you can have a seat, okay? You can take a chair, sit down.
Thanks, sir.
See how we enjoy the class with the kids. A jar of jelly bean candles weigh 8 ounces. A container of caramel candies weighs 40 ounces. Lucia buys 10 pounds worth of jelly beans, candy jars and caramel candies containers for a big party. Given that there are 16 ounces and a pound, which of the following equation correctly relates the number of jars of jellies? This one it's quite verbose in nature, okay? And if I try rushing through it in a minute, you guys will not be able to pay attention to it. So we looked at some of the word problems coming from the equation or deriving the equation based on the word problems. We'll do more practice in the coming class for you guys, okay? So let's not rush for it. What I would instead request or recommend for you guys is, all the other questions that I posted in the WhatsApp group, just try going through it once and see which all of them make sense to you and which all doesn't. And then we'll break our head with those problems in the coming class. Is that okay, everybody? Ria, Praneeth, Sarah, Neil, yeah, Purvi. Yep. So do one thing, okay? Assume that your teacher is not there and there is no class next weekend, okay? I mean, we have class. I'm saying that you assume. And try solving those problems by yourself. And then we'll brainstorm on how you approach those problems and where you felt some difficulty or whatever worked or did not work. We'll talk about that in the coming class. Does that sound okay? Tansi, Ria, Rehan, Saranya. Go and have fun then. Why to waste time with me then? You guys are good? Yep? Alright, take care kids. We'll talk next Saturday.